Welcome to our series on radome and bumper testing, where we'll cover everything you need to know about radome testing and the usage of the powerful QAR50. You were probably wondering what the respective software options are good for and when to use which option. Let me explain the QAR50-K10 frequency response. In order to explain you that frequency option, I have one plate here. This is plate A from our verification set. It's a macro ceramic plate, and we have tuned the resonance frequency of the plate in order to lie exactly in the radar's frequency band. So let's have a look on the measurement result that we have captured on the machine. So on the left-hand side, you can see the well-known reflection measurement, but actually this is not what the software is about in this. The software option is on the right-hand side, and this is where you see the frequency resolved reflection. At this point, cluster 2, but the part is reciprocal, so cluster number 1 looks exactly the same. And we can see that the resonance frequency lies perfectly within the frequency band of the radar, 76 to 77 gigahertz. So what could we use that for? One application could be to adapt the thickness of different plates or different layers, just to ensure that the resonance frequency is always lying within the radar band. Another application could be to actually find the resonant frequency and then, for example, calculate the permittivity out of this resonance frequency. You can also use this option to trace the production quality. So again, if we look on the results, what could be traced? You could trace the minimum frequency, so where the minimum reflection is, or you could also trace or detect what is the maximum frequency that you allow in a certain frequency band. So the option is both for development and could also be used in production depending on the specification and requirements.